Alright, hi everyone. Gonna go ahead and get started here today. Not too much new on the agenda today. We're going to continue to talk about arrays. Gonna go over the in-class assignment from Tuesday. Mainly I'm just gonna go over a bunch of different array examples, show you how to do a bunch of interesting things that you'll need to know for upcoming assignments. And then finally at the end of the class we will do quiz 3. So before we get started, any questions on assignments 4.5 or 5? Anyone start on those? Coming along pretty well, maybe? All right. So we'll just go ahead and quickly review arrays. So clear everything out here. So remember, when you want an array, you would say the data type, the array name, and the number of elements that you want in the array. So remember, when we say something like 10, that gives us 0 through 9 positions. So it's one less position that we actually declare there. And when I say 0 through 9 positions, I mean that you can reference each position by saying this would be the first position in the array. And you could assign something to that if you wanted to. You could say something like this, and that would be the last position in the array. And you could assign another value like that. So, and then you could reference any other position. As long as it was between the 0 and the 9. So when we say 10, we get 10 positions, but just remember that they do start at 0 through 9. So remember, you can set all of the positions of an array like this. So let's say we have 5 positions and we want to set that 10, 20, 30, 40, 50. What we can do is we can say 10, 20, 30, 40, 50. We can statically initialize the array. I can call that statically initializing the array by providing values for each individual position right as we are declaring it. Now remember, you can't do something like this. You can't, after declaring the array, you can't come back and say this. That's not valid. The only time you can use an initialization like this is when you are first declaring the array. So you can also set an array like this, specifying each position. If you wanted to do it like that, you could do it too. This is the only way you can do it after you've declared the array. So, and so on and so forth. The other way we talked about filling an array, initializing it, was using a for loop. So just like normal, we need the index variable, I equals 0, I is less than 5, increment I, and then we'll say r at position I equals I. And that will result in exactly this right here is equivalent to saying this: 0, 1, 2, 3, 4. Filling each of the positions with numbers. So again, you can do it like this, you can do it like this, you can do it like this. A whole bunch of different ways. They're all useful in different situations. So those are all the ways we can initialize an array. So another thing that I don't think I talked about on Tuesday was, if you have an array of 10 positions, and one of the things we talked about before is that we should set our variables equal to 0. Otherwise, random numbers might be popping up in those variables. When we initially declare a variable, remember that it's not guaranteed to be 0. It more than likely will be 0, but again, it's not guaranteed. So let's say we have this array. What we can do is we can set all of the positions equal to 0 by saying this. When we say bracket 0 bracket, no matter the number of positions that are in our array, it will set all of the positions of that array to 0. Now, we can't do something like this. We can't say set all the positions to 1, that's not valid. It's a very specific feature of C that allows us to set all of the positions of the array equal to 0 by saying bracket 0 bracket. So we don't have to say something like this in this circumstance. We don't have to specify out all of the different positions. We can just say a 0 inside brackets, and that's very specific again for the 0 case. Other cases you can't again put any other number to initialize the entire array to. You can only initialize the entire array to 0. So instead of again doing something like this and continuing on, you can again simplify that logic down, in this case, the specific case of 0, to single bracket 0. So just keep that in mind. It's a good practice to set your arrays equal to 0 unless you're assigning a value to them immediately. So talk about passing arrays to functions really quick here again. So let's go ahead and write this print function. So we'll say void print array. So we'll pass in a array. We'll pass in its length. Remember, C doesn't do anything to keep track of the length of arrays. We have to manage the length of our arrays ourselves. So when we're creating an array, it's handy to do something like this. Len equals 10. And then make our array. And keep this variable around. So when we say print array, we say r, and we say len. So we keep track of the length of the array. Now, one thing I didn't talk about on Tuesday that I should probably talk about now as well is that you can actually specify variables as the size of the array on runtime. So one of the things we can actually do is prompt the user for the length of the array actually. So we can say len, we can say enter the size of the array. We'll leave off that new line. Read into len. And now whatever the user specifies as the size of that array will be the size of the array. The only thing to note in this case is that we no longer can use this 0 right here. We can no longer do that because the size of the array can't be determined, and we have to specify this is only allowed when we have a literal number right here. But we'll come back to that later. So right now we've allowed the user to specify how big the array will be. So let's just go through, finish off our print array function. So remember that when we're passing an array to a function, we need to say r and then square brackets. Don't need to say any number inside of that. And when we're passing, when we're calling the function, we just say the name of the array. We don't say brackets. So this is we don't do anything like this. We don't say brackets like that. All we do is say the name of the array, and we certainly don't do anything like this, because that would pass the value stored in position 0 to the function, which the function expects an array, not a single value. So to go ahead and print out our array, what we do is I equals 0, I is less than len, increment I, and print each value. Reference at position I. And finally, print a new line at the end. So right now when we run this, odds are we're going to get an array which prints all zeros. Again, that's not guaranteed because we did not initialize that array to be 0, but we'll go ahead and see what it does anyway. So let's say we want 10. So here you can see this is what happens in this specific case. I mean, it could have lined up, the program when we were compiling it could line up such that the memory just happens to be 0. But again, in this case, we did not initialize that array to be 0. So odds are, and you can see in this case, certainly, that we're going to get random numbers piling up that were left over from other programs running on the system. So, again, in this case, since we initialized it to be the length that the user specified, we can't use the bracket 0. But what we can do is we can go ahead and write a function which initializes the array to a certain value. So we'll call this void init. We'll say int r, pass in the len, and we'll pass in the value we want the array initialized to. So again, just like before, we will need an index, we need a for loop. And then what we're going to do is for each position, we're going to say r at position I equals val. So going to go again 0 to len. So in this case, if we specified 10 for our len here, and our array had 10 positions, when we pass it in, we're going to get 0 through 9 possible I values right here. So all the possible I values inside this for loop, of course, again, are going to be 0 through 9, which are all the possible indexes of our array. And we're just going to go through and set each position of that array to be val. So calling this, pretty simple. We just say init r len. Let's set everything equal to 0 to start off with. So compile that again. Again, I'm just ignoring this warning because I should have a return 0 at the end of main, just a reminder. So we'll say we want 10 positions. And now we can see that we've looped through the entire array, zeroed it out, so that's good to go. We could change our init val. Let's say we wanted to start everything off at 10. That's valid too. Recompile that. Now all of the initial values are 10. So these are two super important functions when dealing with arrays. If you don't have them, you should probably take note of them. So printing array and just initializing array to a certain value, especially like when you first use an array and you're reading, you're doing an operation. You need to ensure that it's 0 if nothing's been stored there or read from there, or so on and so forth. And it's an important function to remember. So, give me a second here. Okay, so let's go on and continue talking about Tuesday's in-class assignment. So, a couple different things. I wanted you to make 3 arrays, one with 0 through 4, one with 4 through 0, and one with random numbers, I think 0 through 100 if I'm correct. So let's go ahead and do that. I'll go into so we have our arrays. We have, we'll just call it 1, give it 5 positions, and 2, give that one 5 positions, and 3, and give that one 5 positions as well. So one of the things I said, it would be nice if you would do this in functions, so we're going to go ahead and do that. So we'll just say void 0 to 4, pass in our array. For that one we would say 0 to 4, pass in 1 there, and then as usual set it up, index, for loop, the I is less than 5 in this condition because we have 5 total positions. And then we'll just say r at I equals I. So pretty straightforward. So go ahead and write the next function. We'll say 4 to 0, pass in our array again. Actually, we need to do this the other way around now, don't we? So we need to start I at 4 and say I is greater than or equal to 0, and then decrement I instead of increment it. So R at I equals I. And that's all there is for that one, I think, if I got my numbers right. And then finally we need to fill one with random, so we'll say void for random and pass that in. Same setup. We'll go ahead and seed the random number generator. If we were going to use this function more than once, we wouldn't want to seed the random number generator again. We want to do that in main, but that's fine. We'll do it here. Remember, if we seed the random number generator again, it will reset its state to the beginning, which is probably fine since we're basing it on time. But if we were basing it on another number, let's say we were basing it on, let's say, a 10 or something like that, we would reset to the starting state and we'd generate the same sequence of random numbers every single time. Alright, so again, same setup for loop. 0, I is less than 5, increment. And now we just say R at I equals rand mod 101. And then finally, I'll just rewrite it, but we need to have our print function as well. I'll leave off the len because all of our lengths are the same. And then we will say %i R at I. And then finish it off with a new line. So after we've, did I say for rand or for random? Yeah, I said for random. And after we've filled all of our arrays, we want to go through and we want to print all of them. So print R1, print R2, and print R3. Now if I've gotten through this entire thing and not made any mistakes, that's going to be surprising. Yep, so I didn't make that many mistakes. I just needed to include sran, include stdlib, and include time. And didn't return 0 at the end again, whatever. And I think I called the wrong function if I... No, I must have messed up somewhere. Oh, okay. So 4 to 0 is actually a little bit more complicated than I thought. So basically what I'm doing here, instead of actually going from 4 down to 0, what I'm doing is I'm just filling the array in reverse order. So you see here I'm referencing I here. These are actually going to end up doing the exact same things because I'm referencing position 4 to start, but still storing 4, and it just kind of goes the opposite way around. So, in order to fix that, what I would need to do, I think, the best way to do it would be to have another counter that started at 0. So I'll have j equal to 0. There's probably a better way to do this, but we'll go with this right now. We'll say j equal to 0. And remember, we can specify multiple initializations and multiple increments by separating them with commas. And then say j++. So we'll say array at j equals I. So I will start at 4 and go down, j will start at 0 and go up. Let's try and recompile that. And there we go, now it makes sense. Now if the whole 4, if all this 4 garbage didn't really make sense, we can simplify that down a little bit. And instead of putting it all inside here, we can say j equals 0. And then after we've stored one value, we can increment j. So those are completely equivalent. Might be a little bit more readable this way, might be a little bit more readable other way. Depends on who you are, I guess. All right, so that was our in-class assignment. Any questions about that? Everybody kind of on the same page with arrays now? Pretty good? All right. So I just want to go through and show a couple different examples of some other things that we would do with arrays. So we got our 2 primary functions there, and that will kind of power what we're doing going forward. But, so we did fill with n, that one's done, so I don't need to do that one anymore. So then we should talk probably about fill with n to m. So instead of filling it with a certain number, we are going to fill it with a range of numbers. So you remember probably doing something similar in assignment 4, where we took and we calculated n to m, and we just printed those numbers out. But it's probably also good to do that with an array and store those numbers in case we need to use them as for operations. Now, there's 2 ways we could go about this. We could say something like n to m. We'll pass in our array. We'll pass in our, well, no, we'll leave off len for right now. We'll pass in n, and we'll pass in m. So the one thing that might go wrong with this approach is, let's say we had an array of less size than the size of the count of the numbers between n and m. So what would end up happening is we'd go off the end, we might fill things farther than we want to. And this is a completely valid way to structure things, but perhaps a better way to do this, instead of saying n to m, is just say we're going to start at n, and we're going to increment n once every iteration up until we reach len total number of iterations. So let's go ahead and do this. We'll say I equals 0, I is less than len, increment I. And what we can do, remember all of these variables, they are just like local variables. They just have the values that we call the function with stored inside of them, so we can manipulate those variables as much as we want. So I will just say r. Oh, there's probably more. There's probably better ways to write this, but I think you'll understand what's going on. So you'll say the value at n. So let's say the first time we're running this array. Right now, all this is going to do is set all of our positions of our array equal to n. But let's say we wanted to go have 10 positions starting at, let's say, 10, and then go up until 20. Let's say we have, again, starting at 10, go up until 20. So what we can do is every time we increment n by 1. So now that we go through the loop again, let's say our n started out at 10, we go around again, increment n by 1, 11. Next time we come around, n will be 11. Just remember that any variable value that we pass into the function, again, won't be modified outside of the function. These are all just copies, except for this. The array is not a copy. All of our normal variables are just copies of the values outside of the array. So let's just take off this init right now, and then say fill n to m. I don't need to do that. I'm off a little bit there. Len, and then we'll start at 10. And hopefully everything works. Wrong file. And there we go, we get 10 up until 19, because we did start at 10 and not 11. If we wanted to get all the way to 20, we'd need to have 11 positions, remember? So if we change that to be 11, we could do that too. So, let's do one last thing. So instead of incrementing by, I'll change this to fill in range. So instead of incrementing by 1 every time, one thing that we could do is specify the step of our range. So we'll add a third variable called step. And what that will do is control how much we increment by or decrement if we specify a negative number each time, each iteration of our loop. So we could say n plus equals step. Now by default, if we want the default value, we just need to specify 1, and that will give us the same functionality as before. Give us 10 up until 19. But let's say we wanted to increment by 10 every time. All we have to do is change our function call rate here to 10. Recompile and run it, 10. And now we can see we are incrementing by 10 every time. So, again, we can change that to, let's say, negative 10 if we wanted to, and decrement by 10 every single time. That's valid too. Now we go down by 10 every time. So think about how you can write your functions so you can reuse them a lot of times. Just by having this one function, I could remove a whole bunch of for loops just because we do this operation so many times, going over a certain range, generating a range that can be used in another function. So that's also a super good function to keep in mind. So we got 3 really good functions here that do a lot for us. So keep those in mind. Okay, so final thing I wanted to talk about was operations on two. We already talked about operations over an array. So we talk about? I think we talked about some a little bit on Tuesday, if I recall correctly. But the final thing I wanted to do was talk about operations onto array and store in a third. So let's say we want some code which will add 2 arrays and store the result in the third. So it's pretty straightforward, I think. R1, R2, and R3. So again, remember when we pass an array into a function, its contents are modified outside of the function, and we'll just pass in length too. So pretty simple logic, I think. We just say int I again, index as usual, just more for loop stuff. Is less than len, increment I. And then what we're going to do is say we're going to store the result of our operation. So we're going to say R3 at I. That's where we're going to store our result. Equals R1 at position I plus R2 at position I. So this is just another simple function to add 2 arrays together. So the first and second parameters, we're going to take those 2 arrays, go through each of their indices, I guess. Go through each of their indices and combine them and store the result in array 3. So what we're going to need to do is make 3 arrays out here too. So we got our 3 arrays right there. And then we're going to, let's fill them up with different numbers, except for A3. We're going to leave A3 empty because we're going to store a result there. So we will say fill in range. Let me go see what the actual fill in range. And we're going to say A1. I think I specify length second, starting position third, and then step. So we will fill it with basically 0 through length for our A1. And then we will fill A2 with 10 up until should be 90 if I'm, or 100 or 90. I'm not exactly sure which one. And then we will call add arrays, add A1 to A2, store in A3, and then we also need to specify the length of all of our arrays. And then finally, we're going to print array A1 len, A2, and A3. So let's see where we are at. Left off something over by 35. Alright, I accidentally had a semicolon at the end right there. Alright, so there's our arrays. You can see that we took this array right here, we took this array right here, we generated both of them with our fill and range functions, and then we combined, or we added those two together, and stored in the third. So it's worth noting that these two original arrays aren't modified at all. We can continue to take those arrays, take their values, use them on further operations if we so choose. So that's kind of the power of storing it in the third array. So yeah, that's, I think, all of the array content that I have to cover for forever. So yeah, any questions about arrays? Anything else you want me to cover before we finish off and do quiz 3? Any content about, so quiz 3 is pretty much entirely about functions. Anything you want me to talk about with functions or anything like that? All right then.